Okay, so continuing with some organic chemistry questions. Today I'm going to take a look at a bit more of the theory questions. So this first one, we have a bunch of information given, different types of compounds with boiling points, and then telling us about solubility in water. And then we want to look at the data and interpret. So the one question, or the first one, says boiling point decreases as branches increase. So if we're taking a look at it, we are actually seeing that as you are adding branches in, like this one has bromine on a branch. Well, I guess it's not really on a branch. It just has bromine in the second position. Over here, we have a branch. So we are seeing that decrease in the second part for 4, 5, and 6 with moving the OH. Same idea. When you move the OH over, and then when you do add in that branch, we're seeing our boiling point decreasing, and we're also seeing its effect on solubility. So the answer here is A, but let's rule out the other ones. So with B saying boiling point increases as the length of the parent chain decreases, the parent chain is getting smaller, but the boiling point is not increasing, it is decreasing. Option C, boiling point decreases as the number of carbon atoms increase. That is also not going to be true there. That would also have to be opposite. And the last one, boiling point increases as the functional group becomes less polar. That's also not true here. It's based on the placement. So the answer for that first one is A. Looking at the second one, this is showing that we understand reactions. So it's asking us about compound 2. So if I look at compound 2, I'm looking at this one here. So coming back over, compound 2 had our line diagram, 1, 2, 3, 4, and then the bromine was on the second. So I just have this like molecule flipped, but it's essentially the same. So this is what compound 2 looks like, and it's asking how can we make it if we're starting with but2ene. So if I were to draw out but2ene, I have this, and it would look something like that. And if I want to go from here to here, I want to notice that the double bond has to be broken. And anytime you're breaking a double bond, that is an addition reaction. So we can take off A and we can take off C. And then the next part is what we're adding on. So if you broke this double bond, that means this carbon up here and this carbon down here can now bond to one more molecule. We know that bromine is definitely coming on, right, to get this one here. But if I wanted to have Br2, I'd have to have another bromine to place, which I don't. I don't have another bromine on here. I have a hydrogen. I know it's there because it's not written with this line diagram. So HBr had to be the one that was added. Now this very last one, we can go back to that first chart and interpret this information. And essentially we have to learn from this chart to be able to answer this last question. So saying using that first table, just to have that understanding, we want to label our compounds that are listed in decreasing solubility in water. Now, the least soluble, without even really looking more into this, is going to be number 2, because this is a non-polar molecule. You have no OH on it at all, so there is no polarity. So it would be non-soluble in water. So that would be the last one. Now, what we saw from our chart was that the longer chain, so like this one here, had a higher boiling point than the other ones. So this one I would put in the 4th position because it has the highest boiling point, so it would take longer to dissolve in water. Then the next one would be this one here, and the most soluble would be this last one, which has that OH group and a branch. So I'm starting with 3, then I have 1, then 4, then 2. As always, I hope you found this helpful. If you did, please subscribe. And if there's any other type of video I could do for you, just let me know. Thank you for watching.